third grade math support. Again, my name is Dr. Greers, and these are our topics for this year. We are finishing up operations and algebraic thinking. Here we had 9 total objectives. We are on the last one for this particular topic, and it is identify arithmetic patterns, including patterns in the addition table or multiplication table, and explain them using properties of operations. For example, observe that 4 times a number is always even, and explain why 4 times a number can be decomposed into 2 equal addends. All right, so let's look at an example problem for this objective. So our problem is an arithmetic pattern problem. In the multiplication table, look at the products of 9. So we have 9 times 1 equals 9, 9 times 2 equals 18, 9 times 3 equals 27, 9 times 4 equals 36, 9 times 5 equals 45. What pattern do you notice in the digits of the products of 9? Explain why the sum of the digits in each product always equal 9. So let's do this 2 ways. Now, I'm going to line it up just because you can see the pattern a little easier that way. So 9 times 2, 9 times 3. And the pattern really only works till 9 times 10. After that, the pattern stops. So let's see, and that's also going to feed into our discussion as well. So 9 times 8, 9 times 9, and 9 times 10. Okay, so for the purpose of this, I'm going to put 0, 9, even though we don't have to, but it's going to help make the pattern really clear. So 27, 36, 45, 54, 63, 72, 81, and 90. All right, there we go. Now, if we look, the tens place goes up every time you multiply, and the ones place goes down by 1 every time you multiply. Additionally, like in the example, if we add the digits in the product, they equal 9. So 0 plus 9 equals 9, 1 plus 8, 2 plus 7, 3 plus 6, 4 plus 5. So this is also a pattern that you see when you are looking at the products of 9. Now, another way we can look at why this pattern happens, and a lot of students, while they're learning the products, they usually stem, especially for the 9s, they usually stem from 10 n minus n, for example. So they know what the 10 multiplication factor is because it's fairly easy. And so they use that, and then they subtract however much they need to subtract, especially for the 9s. So for example, if we did 10 times 9 and then minus 9, well, that would be 90 minus 9 equals 81. And that would help us to figure out what 9 times 9 equals, because this one looked at what 9 times 10 equals. And of course, if we take 1 away from whatever math fact we were doing, then we'll be able to find that 9. And so that's also why this sum of the digits works. That's why we can see this pattern, because of being able to do this particular property. So I hope that was helpful to you. But as always, if you have questions, please don't hesitate to let me know. And hopefully I'll be talking to you all very, very soon. Thank you so much and have a great day. Happy holidays. Thank you so much for joining my tutoring session today. If you enjoy the way that I instruct and you think that I would be a useful addition to your student or to yourself, feel free to scan this QR code. It is going to take you directly to my profile page where you can get set up on weekly classes with me. Looking forward to seeing you in the classroom.